All right, so I have two graphs, and I want to know out of these four choices, which one's a solution. I'm not expecting you to do this by hand. Don't even think about doing it by hand. All right, let's get out your calculators right now. Let's see what these graphs look like, and then you guys can tell me where the solutions are. So go to your Y1 screen right now, Y1. Make sure everything's cleared out from last week. There you go, x squared plus 4x minus 1. Y2. Now there's a problem with the second one. What's the problem with the second one? I can't type that in.
Has to equal to y.
Has to equal y, and this one's not a big deal. I hope. Y plus 3 equals x. What can I do here to get y by itself? Go ahead. So really what we're plugging in the calculator is x minus 3, right? When I bring that 3 over. So those are the two equations that go in y1 and y2. X minus 3. You can take a look at the graph. Go ahead. All right, take a look at the graph. Where are my solutions on here? Where are the solutions? I'm not looking for actual solutions, but where on this picture right here would they be, Frank? Wherever the two intersect, wherever the parabola and the line intersect. So I could see at least 2 points right here that they intersect. All right? I don't want to try to guess, though. I want to make sure I'm exactly correct. So everyone knows you have a table of values, yes? All right, so go ahead, go to your table of values, second graph. And you want to search your table of values, all right, until you see both y values are the same. So there's two spots. Everyone go to, you have -2, 5, and you have -1, -4. Those are both solutions because the y values repeat themselves, right? The y values are the same. So -2, 5 is on both and -1, 4. But look at your choices. Only one of them's a choice. And that would be -1, -4, choice 2. Okay, all by using your calculator. That was it. Press a couple buttons, it gives you free 2 points. Free 2 points. There it is. Every multiple choice is worth 2 points. Free 2 points. There's other ways we could do it, but I think the easiest way is the calculator, and that's the way we're going to do it. Questions? All right, what about number 2? Which statement's true about that graph? What do you think it's a good idea to do? Let's see what the graph looks like. All right, so let's clear out what we just had in y1 and y2. And here we go. Fraction template. 1/8 raised to the x. All right, let's see what the graph looks like. All right, let's look at our choices now. Take a look at your graph. Actually, can I do this? I think I can. Yes, sir. Okay, here you go. Let's take a look at this graph. The graph is always increasing. You guys tell me. Always increasing? Nope. The graph is always decreasing. We're going to shake our head no on that one. Always decreasing. All right, well, we might have to come back to that. Graph passes through 1, 0. Where's 1, 0? Right there. I don't know. I'm not confident, though. I'd like to actually see if it goes through 1, 0. Where else can I go in my calculator to see if 1, 0 is a point on the graph? Go back to your table. Let's see. Is 1, 0 a point? Go back to my table, second table. 1, 0, is that a point? No, 1, 1/8 is, but not 1, 0. So that does not go through 1, 0. Definitely out of there. The graph has an asymptote, meaning a line that it comes awfully, awfully close to, but never touches at x equals 0. Ooh, we got to talk. What is x equals 0? Horizontal or vertical? That's vertical. vertical going through 0. Give me another name for x equals 0. That's the y-axis. Vertical going through 0. That's your y-axis. Does this graph come awfully close to the y-axis? It touches it. It goes through it, doesn't it? It doesn't come awfully close and never touch. It goes through it. So that can't be an option. Remember the always decreasing? A lot of you guys were like, that's not true. That's not true. Go back to your table. Guys, go back to your table. What do you notice about your y values? Keep going down your table. 1/8, 1/64, 1 over 512, 1 over 4096. What's happening? It's decreasing. All right, it is always decreasing. And then we get scientific notation, which is getting even smaller now. All right, so just by going through the table and the graph, that graph is always decreasing. All right, please look at your table, not just the looks of the graph. Please look at the table. Questions on those first two? What, Jeremy?
Actually, 1E.
Yeah, that's scientific notation, which means it's getting smaller and smaller, right? Remember scientific notation, 0.000. It's getting smaller and smaller. That's what the E means, scientific notation. Okay? Other questions here? That's just the first two. First two on the exam. Go to number 30, please. Number 30. This is a part 2 question, worth 2 points still. So worth 2 points still. Is it part 2 or it might be in the part 3 section? No, it's still under part 2, so 2-pointer. And this is something we've done this year, so just a little review. What we've done this year actually does come up. Recursive formula, state the first 4 terms. Let's see how much we remember, kids. Here we go. First 4 terms using the formula. All right, well, what's the first term? Okay, that was easy for you, right? All right, now, using the recursive formula, how do I find what the second term is? Let's remember, 1 plus 2 times. Anybody remember what A with the n-1 subscript? Previous term. Previous term, remember. So once I know that, let's get the ball rolling now. How do I find the second term? 1 plus 2 times previous term. There we go. Second term, 7. Well, let's keep it moving. We got 4 to go. We got 4 total. How am I going to find the third term? 1 plus 2 times 7, previous term. So that's going to be 15. One more. 1 plus 2 times what now? 15. Fourth term. There we go. There's first part anyway. Just knowing that was previous term. And last question. Can this sequence be represented using an explicit geometric formula? Oh, right here. Anybody remember what that meant? Geometric. Geometric. If I know a sequence is geometric. Come on, dig deep. We had an arithmetic, and then we did geometric. What made a sequence of numbers geometric?
A and equals.
No, I don't need the formula. I just want what makes, if I look at a sequence of numbers, I can tell if it's geometric or not because multiply by a number, right? Arithmetic was adding a number. Geometric, multiply by a number. So it's asking, take our sequence, 3, 7, 15, 31. Is that geometric? Am I multiplying by the same number every time to get to the next? So 3 times whatever gives me 7. That same number multiplied gives me 15 and 31. Yes? No? Well, let's find out. Here you go. 7 divided by 3. That'll tell me what I need to multiply by. So 7 divided by 3. Come on. All right, whatever that is, times 7 should give me 15, right? The next number times 7. That doesn't give me 15, does it? So is this geometric? Nope. No, not multiplying by the same number. Okay, that's not a geometric sequence because I'm not multiplying by the same number every time. All right, all good? Just giving you a little taste of what we're, and this is not even anything yet. I just picked some stuff that, 1, we could use our calculator, and 2, something we did from this year. Okay, you can put that away. Put it away for tomorrow. I'll try to do 2 to 3 every day if I can, if we have time. All right, last day of our 4th unit. Day 4.8, I believe. Test, still Wednesday. Not moving it for anybody. Test, still Wednesday. Okay, so you guys that took a little extended break last week, hey, videos are up. You can know where to get your notes that you missed. Wednesday's the test. It's on the entire unit, not just the second half, the entire unit, and we'll review tomorrow. You guys know what my free periods are, and I'm after school, so you guys know the deal. All good Wednesday? We're testing. All right, I'm not moving it. All right, second day of word problems. You guys that weren't here on Tuesday, this is what we did on Tuesday. We did some word problems. Toughest part about the word problems I discussed on Tuesday before break is getting rid of the backstory. All right, get rid of the darn story. Who cares about that? This is a Ferris wheel. All right, I want to know what these numbers represent. So let's read it here. We'll go through real quick. I got 5 feet. Person gets on the wheel at its lowest point, 5 feet. What's the 5 then? Minimum. That's my min. All right, I keep reading. Reaches a high point of 130. What's that? That's my max. And here we go. Next one, it takes one full rotation is 8 minutes. What's the 8? 1 full rotation. How long it takes to start all over again. That's my period. There it is. Those are the 3 values right there. No other numbers are given. I am told it's a cosine curve, so I'll remember that when I start graphing. All good. Why the 5, the 130 are your min and max, and the 8's the period. That's how long it takes to repeat 1 full rotation. All right, let's, I know it's been a little bit. How do I find the A value? 1/2 max minus min. That's a formula going into Wednesday you'll need. Shouldn't be anything new though. Both values are given. I'm going to go through this quick because I need you guys to practice on your own today. 130 minus 5. A value. Should be something and a half here, right?
62.
62 and a half. Okay, we're all good there, everybody. 62 and a half. I always do B for last, so I'm going to skip over. How do you find the C value again?
1/2 x plus 1.
Plus now, plus. All formulas we're familiar with. 130 plus 5. 67 and a half, everybody. Okay, we're good there. Those are just two formulas, got to remember. All right, now B value. What formula do I need that contains B? Period, period, period. 2 pi over B. And you guys got the period right off the information, 8. So 8 equals 2 pi over B. How you guys solving this? I'm taking it step by step here. How you solving it? Okay, let's cross multiply. 8b, right? When I cross multiply one way, cross multiply the other way equals 2 pi. Next. Divide by 8. I don't care if you guys simplify it or not. If it's a multiple choice question on Wednesday, probably will be simplified to pi over 4. I'm not too sure if the problem asked, but I don't care. It's good practice. How about the equation now? What's the equation of this curve? Y equals, what do you got for me? A value, 62.5. Cosine, what goes in the parentheses? Pi over 4 x. Make sure the x is there. And then on the outside, 67 and a half. Yep. That looks pretty nasty, huh? It's incorrect though.
You need negative?
What?
You need negative?
I don't know, do we?
Well, it starts at the lowest one.
Here we go. Good. Here we go. Good catch. Ryan says, hey, wait a second. Look, reread it. A Ferris wheel such that the person gets on the wheel at its lowest point. Cosine usually starts where though? Where's cosine usually start? The max. But I hate to tell you, what's the max again? 60, what is it? 130 is the max, right?
Yeah.
I don't think somebody's going to take one huge leap 130 feet up to the highest point, right? So they get on at the lowest point. How do I represent that in my equation again, Ryan? I got to have a negative. There you go. Good catch. Got to have a negative because we're going to start at the minimum, but cosine usually starts at the max. That's a tough one right there, getting that little shot. All right, ready to graph? I thought about it over the weekend, doing all these answer keys for your review tomorrow. Here we go. I would start first with your y-axis. You need 3 values for the y-axis. 3 values must be placed on the y-axis. All of them which you have right now. The minimum, which is 5. The max, which is $1.30, needs to go on your y-axis. And midline. How do you find the midline? It's the shift. It's their C value, everybody. C value, shift, midline, all the same value, which is 67.5. Those are the 3 values you need on the y-axis every graph. Min, max, midline. Now let's do your x-axis now. Anybody will remind me how to break up the x-axis?
Key values.
Okay, yep. What about them? How do I do the key values?
You divide it by 4.
Key values is the period, not the B value. The period, which was what?
8.
8 divided by 4. I'm going every 2. Every 2. So that's what I would suggest every time you need the graph. Min, max, midline for your y-axis. Divide your period by 4 for key values on the x. All right. let's actually do it now. Move this over here. 1, 2, 3, 4. 1, 2. My first tick mark will be what? What are you going to put on? What number are you going to put on your first tick mark? 2, right? And then I'm going to go by 2s. 2, 4, 6, and your last one should always be the period. Y-axis, that's your choice. I need 5 all the way to 130. I need 5 all the way to 130. It's your choice what you go by on the y-axis. I don't know, I'm probably thinking 10s here, maybe, everyone. But that's your choice. You want to go by 15s? Sure. Looks like I'm going to go by 10s. I don't need to show all of them, just to show I'm going by 10. 30, 40, 50, 70, 80, 90, 100, 10, 20, 30. Guess I could have went by some other stuff, but. Where's this graph going to start? Minimum, right? Because he gets on at the lowest point, which is, what's our minimum? 5. So we're going to start at 5. Okay, think about the cosine curve. Where does it go now? Midline, 67.5. Usually it'd be at its minimum at this point, but we flip it, max, $1.30. Back to the midline. And we end at the minimum in this case. Usually we end at the max, but we're flipping it to end at the minimum. And there's your Ferris wheel. A lot of work goes into this. There'll be one problem like this on Wednesday at the end of your test. One problem like this where you got to give me A, B, C, graph it. Questions here? All right, I'm going to save some time. I don't want to do the next one. This one was more of a little bit of a challenge one right here, so I'm not going to waste time in doing this one. You guys need some work on your own. So here's the deal. I want 4.7 done first. So you're going to go back to Tuesday's assignment if you haven't done it. Then you go to 4.8, which is what we're on right now. Okay, so in that order, please. 4.7's work to 4.8's work. Everyone should have their Chromebooks open to the Google Classroom answer keys. All right, so 4.7 work first, which is, just want to make sure I get the pages right. 33 and 34. So pages 33 to 34 for me, and then you're moving on to page 36 to 38. If you want to work with somebody else, feel free, go right ahead. But let's get going here. Have your answer keys out as well. Have the answer keys out as well. We're already done with the notes, so you do what you got to do. Here we go.